Hi, welcome back to the breadboard. Today in this video we're going to have a look at the Super Starter Kit Uno R3 project box. This came from a company called Elegoo. They sent it to me a little while ago to evaluate, and now we're going to go through and I'll show you how to install the software and run through the first few tutorials, which is really basically getting everything set up ready to use. In subsequent videos we're going to run through the actual tutorials that are provided with this. So without further ado, let's get going. Now the first thing we're going to do is open it up. So we have CD for it. I'm going to put that in my computer right now, and then we will start going through the setup procedure right to the point of being ready to do one of the tutorials. So there may not be much to look in this part of the screen, but I will overlay the instructions and what's happening on the computer. I'm recording that at the same time. So we've got the PDF, we've got the CD in now, and if I open it up, what we have on the DVD is a whole bunch of PDFs, data sheets for all of the components that are in here pretty much that I've seen, which is excellent. That's nice to see that. We have tutorials, etc. in all different languages: Dutch, English, Spanish, French, Italian, Russian, I think, Chinese, and then we've got an FAQ for the Uno R3 driver. Now in our case, where's the Uno board here? Alright, so we've got the 18 mega, probably a 16U4 or something like that, USB microcontroller. So this is normally detected automatically by Windows 8, Windows 10, etc., etc. So you shouldn't have to load a driver. Now other versions of Uno boards do have different serial driver chips in that you use to communicate with the USB and into the 80 mega 328p that's on here. In our case we should be fine, but we'll find out when we plug this in. So first thing we'll do is we're going to go into the English, and what we have here is a data sheet, PDF. We've got the driver one again. We're not doing this on Linux, so we're going to go in and have a look at this PDF right here, and I happen to have that already open right here. So Elegoo Super Starter Kit for Arduino Uno, well, for Uno. Coming down, preface about the company, where all the storefronts are if you want to buy more parts for the kit. This is all available, by the way, on the Elegoo website. You can download all of these PDFs and everything as well. In fact, I have the Elegoo downloads, so www.elegoo.com/download, and you can see you can get the Arduino IDE, you can download the software for the car, balancing robots and other various projects that Elegoo sell, including their 3D printers, different kits. So if you've already got an Arduino Uno or a Mega, you can get sensor kits, TFT displays, etc. Quite a range of different things for it. A whole bunch of 350 or 600 LED kits, stepper driver kits, presumably for 3D printing control and things like that, and then some nano boards as well, which is down here, which is great. So they have quite a range of support capabilities. If you want the very latest in drivers, then you would probably go into here. What we want is for the Elegoo Uno R3 Super Starter Kit. I just finished doing a video on their robot car, so let's save that. Once it's downloaded, we will open it, and this is the one we want to be opening. Alright, so back to downloads. We should have another one now for the starter kit, not the robot car. Okay, so we have the latest files here. We go into English, we'll open up the PDF for the starter. If we look at what we've got here, by the way, before we do that, we've got a folder which is full of code. These are all the different tutorials. Notice it starts at lesson 4 because lesson 1, 2, and 3 is getting everything, your environment set up on your PC. I have a Virgin PC here. I just finished setting up Windows 10 so that there's nothing pre-installed. So we'll see everything that happens, warts and all. So we'll go through these tutorials in a separate video. For now, let's go back up one. Sorry, I want to stay in there. You've got libraries. So these are all the libraries for the different devices that you have in the kit here, where you need them, which is good. And then we have the PDF for where to start. So let's make that a little bigger, and we'll start running down. So this is where we were before, but now we have a later file. So this is your kit manifest, basically, all the pieces that you've got with it. Displays, motors, sensors, potentiometers, buttons, DuPont connectors, LEDs, diodes, transistors, etc. So lesson 0, so you've got lesson 0, 1, 2, 3 here. These are all just getting things going. So we're going to do these now. So lesson 0, installing the IDE. Okay, so you go to the Arduino website, you can just click on the link right here. Brings up a screen like this, and over here, there is the actual page. Let's just get these back in order. That you would come up with. Now, the version of the Arduino IDE is going to be different because time has gone on. We're up to 1.8.10. Now, there are a number of different versions. You can run a web-based Arduino IDE, which is great if you've got internet connectivity. I prefer to run local. You can run an installer, which will give you a completely local Windows-capable Arduino IDE. You can run the Arduino IDE, which comes down from the App Store, which is like a traditional tiled Arduino IDE or traditional tiled Windows 10 app. You can download for Linux and you can download for Mac. So the one we're going to download is the Windows installer for XP and up. So you just click that. You can choose to contribute. You know, if you're going to use this a lot, it's only fair because you're getting all of this for free. So, you know, chuck on a couple of bucks if you want to. Otherwise, just hit download, and we save. That's done. So now, to start the installation, let's go back to here. It says to download it from the website. Talks about the options, and then you basically start it running. Okay, so we're going to do that right now. We're going to hit run. And we're going to say yes. Right, so here's our license agreement. We'll say agree. And if we go down here, nice that I can do that without losing the top one. All right, we'll leave all of the options on. Just click next. Same, click next. We don't have to change any of these. It's all automatic. It may pop up for some questions while it goes. It won't take very long to install on here. All right, so installing software, Adafruit Libraries LLC. This is for the COM ports. Adafruit has been doing a lot of work with Arduino, providing support, extra I/O, even making things for them. So it looks like their new COM port drivers are coming from Adafruit now. So we just click on install. You can, if you don't want to trust it and be asked every time, you can uncheck this here. I do trust it from them, so I'm just going to say go for it. These are more drivers, so again we'll say install. This one is from Arduino SRL this time, and Arduino LLC. Okay, and we should be almost done. Let's just scroll down on here. Done that, got that done. All right, so this is, yeah, we should get a desktop icon when we're done. And we're completed over here. Wasn't paying attention, so we'll close that. Go look at the desktop for a moment. Minimize a few things here. And there's our Arduino icon. So double click that. We'll open up. And we get the firewall blocked, allow access. And here we go. So I haven't plugged in the Arduino yet right here, so let's just get this. There we go. You can see the lights flashing. These always come with a blink sketch pre-installed on them usually, which is what it's doing. It's going to be flashing IO pin 13. So now if we look in Windows drivers, or control panel, and you go to hardware and sound, device manager, we should see a COM port that is recognized as the Arduino. If we don't, we would have to install a driver as per. But here we go, Arduino Uno on COM3. So you need to remember that this is on COM3. Mind you, there's only one, so it won't be too hard. Your computer, if you've got other COM ports and other devices, may come up with a different number. Just look for Arduino Uno and then note what COM port it's on. Alright, now we're going to add libraries. So this is lesson 1 now. So we've got the IDE installed. We didn't count that as a lesson. Now we've got lesson 1, adding libraries and open serial monitor. Why we need libraries is a lot of these devices that are on here, people have gone to a lot of effort to create what you would call drivers. So in Windows, when you plug something in, you would have a driver which would allow it to work for you. So your interface is really, really simple. For things like this, which is this is a 2-line by 24 character or 20 character LCD display, you could write all the code, which would be a royal pain in the butt, to talk to this, or you can simply take a library where somebody else has already gone to the effort of writing the code to talk to this and wrapped it up in a nice little bundle and made it available for everybody. And the benefit of that library is you can just write your own program, not worry about the intricacies of how one of these LCDs actually works, and then you can call the library to put things on the screen. The same thing will go for things like the ultrasonic, the DHT22 temperature humidity sensor. There's a lot of different things that are in here where a library will make life much, much easier for you. So let's go through and do the library installs. Alright, that's better. See, the IDE is actually already saying let's update some libraries. So I'm just going to say yes to that to bring it up to date to start with. Alright, so here's 2 that are already needing update. These came built in. Alright, so we're going to update that one. And we're going to update that one. Doesn't take very long. I think I must have accidentally got all of them showed up there for a second. So now we can close that. So those are the updates done for that. Now what we're going to do here, all right, it wants us to manage library. And in the library manager, so you can pick from libraries if they're already available. That's why having an internet connection on your computer works very well, because you can go straight to libraries. You can manage libraries. I'll have that pop up. And here are all the libraries, not all, there's a few of them that will be already installed, but there's a whole bunch of libraries now here that are listed. And if you wanted to search this way for them and install them, you can. And it'll install them directly, which is the much easiest way of doing it. But you can also get libraries as zip files, and that is what comes on the DVD that came with the kit, is so that you can just load libraries from there as well. What we'll do is we're going to follow whatever it says in these instructions here. I think this is just telling us right now about the libraries, or how to use Library Manager. It's very simple. You can pick, so let's just pick something here for a moment. APDD9960. It's a color and proximity sensor, looks like it. So you can pick which version you would want, so you can go for an earlier version if you want. Sometimes the latest version may not work in the application you're doing, because one of the other libraries might depend on something from an earlier one that is no longer supported. And then when you pick the version you want, you would just click on install and it would go in. All right, very simple. So for instance, we have a DHT22 sensor here. We can, up here in the search, we could just type DHT22 and it'll go away, and it, lo and behold, here it's found in our Arduino library for the DHT11 and 22 temperature humidity sensor, and we can just click install, which is what I'm going to do right now because we will be using that at some point anyway. So you just click install, install all or just the library. When you say all, you actually get sample code as well. So we're just going to say all, because then we'll get some sample code in there. And that's done, right? Easy as that. And you can do that for each of these devices. If you're not 100% sure, you can just type in the name. For instance, this LCD display, typically known as a 1602. For the LCD display, they simply call the library liquid crystal. So you can go in here and click it, examples. Now we should find down here liquid crystal. There we go. All right, we added the DHT one before. Now we have the liquid crystal one. So if we go back to the other one just for a moment, manage libraries, probably the one that was on the DVD is not the latest one. So see, the latest version is 1.0.6. I'm not sure what version we had. It hasn't analyzed it yet. But we can update and put the latest one in here just by doing that, and then that would have overwritten that library now with the latest one. So very easy to manage the libraries. All right, let's scroll down here. So here's the example where they're using the ones that they provided on the DVD. Manual installation. Don't recommend using the manual installation. It's a bit of a pain compared to the ways I've just shown you. Making a connection to the Arduino is using the COM port. Now remember, I said this is using COM3. So if we go up here on the right hand side, that little serial monitor icon, if you click it, it's going to connect to the serial monitor. But we've got an error here because I haven't told it what COM port it's on yet. So we go down to port and we'll pick COM3. There's only one listed anyway in this case. Now we should be able to, I think, get board information. Yeah. So there we go. It told us a little bit about the board, including its serial number and things like that, what it is. And now, and you can pick different boards as well. We're only interested in the Arduino Uno. Now the Arduino Uno versus a Genuino Uno, the only difference there really is one's made in North America, one's made in Europe. And we'd still, even the Elegoo Uno R3, we would still pick Arduino Uno for that. Yeah, everything else we're going to leave as defaults right now. So now we should be able to connect because I picked a COM port and now we can. It's not going to do anything right now because we don't have a program loaded to make any use of it. All right, this is showing the same thing, and there's the screen. You can change the baud rate. Now the settings in your program, you set the baud rate. So if you do change it from its default, you would need to set it. And I think by default right now, this is set to, where's my COM port gone here? So it's set to 9600 by default. You can go all the way up to, well, very fast, 2 megabit if you wanted to. Typically people use around about 115 K2 board is very typical. Everything works just fine. Okay, so lesson 1 is the blink sketch. Now that's the one that I told you is already on here, which is why when you look at this, that LED there is already blinking. So we're going to open the blink sketch in the Arduino IDE, and we'll just quickly change it to change the speed at which that blinks, just so you know things are working. So the sketch is right here. You go File, Examples, and Basics, and Blink. So we'll do that ourselves. We go File, Examples, Basic, and there's the blink sketch. You can just click it, it opens. Now Arduino IDEs open additional ones, which is a bit of a pain, but here's the sketch. It's very, very simple. Actually, if I just change the font size, I think, to make it easier to read, you go to Preferences, and you can change the font size. I'm going to make that like, I don't know, 20 font, something like that. So what this sketch does is, the first thing here, there's always two parts to an Arduino sketch. There's a setup and then there's the loop. These two pieces are always there. You may get a whole bunch of other functions. That's what this is called when you've got a little container here. You've got the name of the function, in this case setup, open and close brackets. In between there you would put parameters if you needed them. Setup doesn't have any, nor does loop. and then you have an open squiggly bracket with a matching close, and you see how here when I click near it, it highlights the matching one. So if I click this one, you'll see it's highlighting that one, right? So everything contained within this is part of setup. Now the only thing it's doing is calling a pin mode, which sets up the mode of one of the pins, and then LED built in, which is typically pin 13, and then it's setting up as an output. I'm not going to go into anything more complex than that right now. The loop that it's doing here, so what happens is the underlying firmware will call setup once, and once only when you power up the device. It will then continually keep calling loop. So here, see, loop is going in, it's running through, there's nothing to keep it inside here. When it gets to here, it's just going to return to whatever called it, which is not setup. You can do things inside here to keep it here if you want, but it's not necessary because the underlying system will keep calling loop anyway. So what this is actually doing is its digital write will output to one of the pins. It's saying the LED built in, which in this case is 13, set it to high. That's going to turn the light on. It's going to wait 1 second. This delay is milliseconds, so there's 1000 milliseconds. That's 1 full second. And then it's going to change it to low. And then it's going to wait another 1000 milliseconds. All right, and you can see that's bouncing on and off at a 1 second rate. So in order to show this working, I'm going to reduce this to, I don't know, 500, so half a second. Should speed it up a lot. All right, so we've made some changes to our code. Now we're ready to what you call deploy it, which is actually to send it down the USB to the device. And you can you can check your compilation, which will verify that everything is correct. So for instance, if I went and put something silly in front of there and I hit verify, it's going to tell me there's an error, right? And it even highlights it. Right? If I get rid of that so that it's correct again and redo the verify, it'll compile it and it will say everything's okay. It's doing a bit more this time because it didn't find any errors. Right, done compiling. I scroll this up. So that sketch here used 924 bytes, 2% of the available space. It's got 32K available. All right. So now we know it works. We want to upload it. We hit this upload button. And what I want to point out when I do that is there's going to be a couple of lights going to flash on here. Let me adjust the camera to be a bit closer. All right, so when I hit upload, you'll see this transmit and receive lights flickering on and off while it does its thing. So let's hit it now, upload. It's going to recompile the sketch. Now it's done that, and you can see the lights flick there for a second. And now you can see that that is blinking at a much faster rate. And if I change it even more, make it say 100 milliseconds each one, and you can make it compile straight off if you're comfortable. Now see it's uploaded and now it's blinking much faster. Okay, so first sketch done, and you can see how easy it is just to toggle a pin on and off on the Arduino. Very easy. There's a lot of other options for this, but that's for another video. So let's go down and see what else it says here. Often if you connect here, and there's, like, so you can see the errors here. This is AVR Dude. Now AVR Dude is an application that runs behind the Arduino IDE that specifically knows how to talk to the Arduino bootloader and send code up to it and things like that. So if you're getting errors like shown here, that probably means that you've got the wrong COM port and you don't have an Arduino Uno connected to the one you selected, or it's just not plugged in. So check it, make sure your power light's on, things like that. Let's go down a bit more. All right, so in this case they're showing int LED 13. Just to show you that I'm not making things up here, where it says LED built in, I'm going to change that to just say 13. I'll change this back to something a little more easier to see. And then we'll just say upload that. I think that's enough. I don't have to say anything else. Yep. it's done uploading, and you can see I've actually written the words 13 this time. So what I had here before, which was what was in the sketch with LED built in, is a convenient way of not worrying about what pin numbers are. So it's effectively an alias for the real pin. Now, I guess technically that's not the real pin either. It's the way that the Arduino maps it out to their sockets. It's not the pin of the chip, it's the pin of this, right? So just remember that. If you're ever going to pull one of these out, put it into a PCB or something, it's not going to be that pin. You still reference it as that pin, but it won't be pin 13 on here. It'll be something else. Again, another video. So this is going through what I've already discussed with you about how it works, and change there. See, they changed the value to 500 too, and I did not read ahead. All right, lesson 3, LED. This time we're going to use the breadboard, and we're going to use a few of the parts that are on in the kit, and we're going to make an LED turn on and off. Where are we now? Link. So in this kit we need an LED. Now it really doesn't matter which color we pick. We just need one. So let me just zoom out a little bit because we're going to need the space for a few things. There we go. That'll work. Let's move back a bit. All right, so we need an LED, so we're just going to pick one of these. They say red, but hey, you know, we got lots to pick, so we'll pick a red one to start with, but it really won't make any difference. We need the breadboard, of course, here. So there's our red LED. We need a 220 ohm resistor. So underneath here, we have all of these resistors. Now resistors are color coded as well. Now it happens for convenience that they've written the values. So there's 1K, 10K, 10 ohms, 220 ohms. So that's the one we want, one of those. 330 ohms would work as well, be just a little bit dimmer. 100 ohms, 5K. Yeah, so you got a whole bunch of different values. Now these have got color codes on them. Again, topic for another conversation. But 220 would be red, red, brown. A red from a color code perspective means 2. Right? You start with 0, which is black, 1 is brown, 2 is red, 3 is orange, 4 is yellow, etc. So there'll be a band which is red. You can't see it very well there. But it's going to be red, red, brown, and then a tolerance. Okay, so I'm going to pull one of these out because that's what we need. And see, once it's out, there's no way, you're not going to get it pushed back in, and you're going to have to now try and remember what value it is. So if you know how to read the color codes, you can figure that out. So there's our 220 ohm resistor. We need a 1. Oh, okay. So just teaching us. I should try and read this. I'm cheating. So we need 220, a 1K, a 10K. So we need the 1K here. This one is going to be brown, black, because it's 1, 0. And then it's going to be 3 more zeros. So it's going to be probably an orange. Or they have more bands on, in which case they're going to be something different entirely. Different resistors have different band schemes. You can buy them with different tolerances and things like that. So sometimes you'll get 3 bands, sometimes you may get 4 and things. So what we've got here is ones with 4. Here's a 10K, I think. Yep. There's our 10K. So we're going to pull one of these too. So that's 1, 0, and then 3 more zeros. So we've got we've got a brown, a black, which is 1, 0. We've got a brown, black, which is a 1, a 0, a 0. So that will be 100, and then we've got a red, which is 2 more zeros. So another one, another one. That basically makes it 10K, which is what we've got. So these are 4 band ones. The last one in the band sets is always the multiplier, which basically says how many zeros afterwards you've got. Just a point to show you with these LEDs, by the way, there are some that have 4 legs on them. These are RGB LEDs. These other ones, which I'm throwing around here, have got 2 legs on them. Okay, these are just single color LEDs, unless they've got some special chip in which might rotate colors. A lot of Christmas tree light type things have that. In this case, they're just single color. In this case, the red one has just got the 2 wires on it as well. And we need jumper wires. So, component board, breadboard here. So, a little bit of information about the LEDs. The longer wire, if you haven't clipped them, is the positive. The shorter wire is the negative. You'll also notice if you do clip them, there's a little flat. I'm going to have to put an image up for that. There's a little flat on the side of the packaging, which also indicates the negative end of the diode. All right. So if you did clip these shorter for some reason, you would still be able to tell because of that little flat edge. All right. Anyway, see what it says to do. I know what to do, but I'm just, oh, here's color codes. So nice is that it's showing you a bit about this. So this one's got a red, black, and a brown. So it tells you about them. Here you go. Nice little color code band. The ones that came in this kit are actually 4 band plus a tolerance, so it would be 5. It basically works the same. It's just that you've got an extra digit and then you've got the multiplier at the end still. Anyway, you may get different ones, so just be aware of that. But the principle is they work the same way from how you figure out what resistance value they are. Now we've got diagrams. I'm going to hide this for a moment because we want to look at this diagram a bit better. So what we're going to do is we're going to hook from the 5 volt from the Arduino, just because it's convenient to do so. We're going to go through the 220 ohm resistor, through the LED. This is the electrical symbol for an LED. And then we're going to go back to ground. Okay, so on the Arduino Uno, this end here, you can see here we've got the V in, which is going to be the volts that's coming in. You've got ground times 2, then you've got a 5 volt, then you've got a 3.3 volt, then a reset, and then an IO reference, which is the reference voltage from the chip here. So what we're going to need is the ground and the 5 volts out of the Arduino Uno to plug into our board, right, to do this here. So here is shown in a diagram. There is a program called Fritzing that will let you do these diagrams like this, by the way. So let's just lay this out as they've done it. Okay, we're going to get a couple of wires from our pack of wires. We're going to grab a red one because that is typically used for plus, and I need some cutters to go. We've got a red one and we want a black one. We've got a black one. So we're going to jump at the black one from the ground pin on here. So there's 2 of them. So just push it into the socket and push it into the blue line here. And then the red one, we're going to push into the 5 volt. By the way, on this board, it's also written on the outside of here. So we're going to go into the 5 volts, and that will go into the other side here. Okay, so now that's brought that in. Let me just zoom in closer for this, just so you can see a little easier. Okay, there we go. There's nothing else you particularly need to see right now anyway. So what they have is they've got the diode linked. Now remember, the short one is the negative. Focus. There you go. Short one's the negative. And we splay the legs out a little bit just to make it easier to put on the board. This will just push in. So we're going to plug it into the negative right here, and then just really any pin across here. It doesn't really matter which one, like that. Now nothing's happened yet because what we have here, get a pointy thing, is this blue line represents a power rail which goes all the way down. So all of these ones are all connected together, going all the way down to the bottom. All the ones next to the red one are connected all the way down to the bottom. These ones here are only connected this way. So there's 5 of them, 1, 2, 3, 4, 5, connected 5, 5, 5, 5, 5, 5, 5, all the way down. So that one, what I've plugged in here, is connected to the ground. This one is just connected to these 5, but it doesn't go anywhere else yet. In order for a current to flow and the LED to come on, you need to have a complete circuit. So we'll take the hopefully 220 ohm one, red, red, black, black, so no extensions. So we're just going to drop it into the 5 volts. And you can see now the LED is come on and it's quite bright there. So you've got 5 volts going through it, and then the resistor is dropping some of the volts because there's the same current going through the resistor and the LED. And because it's the same current, because there can't be anything else because they're in series, then you get a voltage drop across the resistor and a voltage drop across the red LED. The LED is typically going to be about 1.6 volts. In fact, if you just give me a second, I'll grab a meter and we can have a look. All right, back. All right, little meter. So, got my meter. Let's just hook it up and see what we're dealing with. So the first thing is to measure the supply voltage. So we'll go across between the LED leg and the other end of the resistor. Wasn't connected there. So we've got 5 volts, 4.96, close enough. We go across the LED, which is also halfway through the chain. We've got 2 volts. So we've got 2 volts across the LED, which means there's about 3 volts across the resistor. So you can figure out what that current is. But for now, you can see what voltage is across that resistor, which leaves the volts across there. Actually, the current is important, really, for this. So, the current is I equals V over R. It tells you the current. So we know there's roughly 3 volts across this. So, and we know it's 220 ohms. It's I equals V over R. So 3 divided by 220 tells us we have about 13 milliamps flowing through there. So now if we change the resistor, right, so we're going to pull the next resistor out. So this one looks like it's brown, black, black, brown. So 1, 0, 0, and 1 more 0. So that should be the 1K. The LED should be a different brightness, and you can see immediately that that is. It's a lot dimmer. So if I quickly put it back again, all right, how bright that is versus how bright that is. A lot dimmer. So this time, there's going to be a lot less current if we measure the volts across the resistor this time. 3.12. Right, so 3.12 divided by 1000. I equals V over R. Right, that's going to give us, right, that gives us 3 milliamps that's going to be flowing through there. That's a lot less than we had. We had about 18 before. Now if we take this one out and we put the other one in, which is our 10K, we're probably going to get maybe 0.3 milliamps, very little. You can see there it's barely on at all. And if we measure the volts across this one, all right, we've got 3.24 volts across there. Now remember I said that the diode is a current device. So this is not changing volts as much as you think it would, but it's massively reducing the current because this diode won't even start conducting until it gets close to its on voltage. There is a threshold. If it was 2 resistors, we'd get very different results. Because there's a diode here, this is not doing what you may have initially expected. So we said it was 3.2 volts. Close enough. All right, so 3.2 volts divided by 10,000 is going to be 320 microamps, so way, way less. So if you want to have something that conserves a lot of power, put a bigger resistor in for something like an LED. All right, so that's good. So that is less than 3. Now, what I want to do just to finish this is the example here where they wired it up. RGB LEDs is less than 4, so we're getting a bit more complicated. And I'm going to reserve that for going into doing code as well. I don't want to make this one too long. I want to make that light blink from one of the pins of the Arduino. So I'm going to put the bright one back in again, the 220 ohm resistor. With this 220 we're drawing about, I think we said 8 milliamps, I think, or 13 maybe. It won't go over 13, but the resistor has 2.96 volts. It gives us 13 milliamps, right? So we're probably at the limit of what the chip would be able to drive, but it does have protection in to a certain extent, so you're not going to damage it with that. So what I'm going to do is I'm going to take it from the +5 here, and I'm going to connect it to our pin 13, which is busy flashing away here internally. All right, so now you can see it's flashing that light in sympathy with this one. Now, if you really want to get clever, we'll do a quick program change just because we can. I'm going to connect it to pin 12, which is not doing anything right now. And then we're going to go into our code in Arduino IDE. And we're just going to tweak it a little bit, just, well, because we can. All right, so we're going to initialize, we're going to copy this bit of code here. And we're going to do pin 12 as well. All right, that's all I got to do to copy it, nice and easy. So we want to write high for that one. We're going to do, we're going to make it do the opposite. So I'm going to say 12 and then low. And then we're going to do this one. We'll do 12 and we'll make this one go high. Okay, that's all I've got to do. Now I've actually added another pin. So now what's going to happen is when that one's on, this one will be off, and it's going to alternate between them. And what it's actually doing is alternating these two pins here. All right, so let's just run that and compile it and send it out. I guess I need to slow that down. It's still running quite fast. And we'll send that out. Blink. And there we go. Right, so we just done our first modified sketch. There are going to be plenty more. In the other ones, I'm not going to go through how to install the IDE. If we do need to install a library as we go, we'll quickly cover that, because inevitably when we use some of these other devices, we are going to need to do it. Obviously, all these different things in here. Now, one of the things you just saw me use, which you may not have, is a little multimeter. This one is the little very portable one from RS Components. You can get multimeters from all over the place, Banggood, your local hardware store and things like that. So, you know, don't feel like you have to have one this kind. But you can get, you know, having a little multimeter is very useful for this kind of thing, so that you can measure voltages and things like that. I think I have another example of what one might look like that you could get. One sec. Yeah, so I've got one here. This one also happened to have come from RS Components, but this one's $20 or $30 as well. Gives a nice 3.5 digit display. 3.5 just means it's 3 zeros, and then you can have a 1 or not at the very side here. It'll do current, it'll do volts, etc., etc. This one won't measure current. This one will. This one also auto ranges for a whole bunch of things. So much simpler device. This one, you set the range you want, so you can easily measure things like resistance. All right, if I go to resistance and I set it to 20K, for instance, I can take one of these resistors. I don't know which one it is that I picked up, but we just put it in the resistance. And there we go, it's measuring 1K in this case. I can flip it down, get a bit more accurate reading. 992 ohms. If I take the other one, which is the 10K, it's not going to read right now because I'm on the wrong range here. All right, so I flip it up one, and it'll tell me it's 10.01K. And the one I've got flashing, very quickly pull that out. All right, this one's going to be 220, so if I go down a range, it'll show me that it's 218 ohms. Very nice, very easy. This will also check diodes, check batteries, measure current up to 10 amps, AC volts, DC volts. So it's quite a handy little device. Some other ones you can get will also measure capacitance, which can be useful. So little device like this. And the one thing to pay attention to is some of these cheap ones, they don't have a true what they call CAT rating. They're not really rated for use with mains voltages and things like that. They're only good for hobbies like this. If you're starting to use something that is for mains, and you can be wiring up solenoids and relays and connecting mains to them and measuring them, then you really want to get something that is suitable for the job, that doesn't put you at risk. One of these, if you buy a cheap one, not this one is actually certified. This is only about $30 or something, maybe not even that. You can get some which are sort of like $5 or $10, but you risk them blowing up if you connect them wrongly to a high power source, like the mains. Then they could blow up in your hand and burn you or hurt you, or or somebody else or whatever. So just be aware of the fact that you get what you pay for. Shop around, make sure it's certified. Depending on where you're from, might be CE, might be UL listed. It'll have a category rating. This one's 600 volt. Yeah, this is a Cat 3, 600 volts rated. It's written up there. So having ones that are Cat rated would mean that it is certified for different environments. Cat rating don't mean the voltage necessarily. It means whether you got low voltage, whether you got from the socket in the house out into the room, whether you do distribution power, or whether you can use it in a power station kind of things. That's more about what that's about. And you can look up Cat ratings if you want, if you're interested to find out more. Anyway, getting one of these or something like this would be handy for your hobby if you're going to be doing it for a lot. Not essential, but if you're not using that, you need to be able to read what's happening. And you saw when I was trying to figure out what current was flowing through the diode here, I was putting in the probes and measuring the voltage across the resistor. Knowing the resistor value, knowing the voltage across it, I can calculate the current very, very easily. Anyway, I think that kind of covers that for now. Let's just put that back in so you can go off on a flash with a flash. Okay. There we go. And that's it. So that's our first experiment with the Elegoo Uno R3, basically lesson 1. So we're off and running. Next we'll be going to do that was lesson 3. Lesson 1 was installing, lesson 2 was putting in libraries, lesson 3 was how does an LED work, and I gave you a bit more than what's just written in there. Lesson 4 is using multicolor LEDs, and we will follow the lesson, and I'll also show you how to do a quick bit of code change to make it work within your Arduino IDE as well. In fact, there is code for it. I think we saw that, did we not? No, don't want that. File manager, yeah, code. Lesson 4. There should be, yeah, there is. All right, there is code in here. And you can download this code for yourself. You don't have to even have an Arduino kit or something yet. So this one is doing something fancy with the code. We'll go through it and we will try it out in the next video. So there you go. That's the Elegoo Super Starter Kit for Uno. Right? All the components you need: resistors, diodes, LEDs, light emitting diodes, all sorts of things. And we're going to have lots of fun with this. And if you didn't catch it already, I've just published recently the video for the Elegoo Smart Robot Car version 3 as well. We haven't done anything with this yet, but we will also be doing experiments with this and running through the tutorials for this one too. A little bit more advanced. This one's dealing with motor driving and everything else. This one we're dealing with some of the more basic Arduino coding and components. So I'm going to be doing both of those in parallel, switching between the two of them on different videos. I will mark them up appropriately so you can follow along. Both of these are available. I'll provide links through to the Amazon store where you can buy them. I will use an affiliate link. It won't cost you any more money, but it will help me support my channel. And so yeah, if you like it, go get one for yourself. If you order right now, you get it before Christmas. And if you liked the video, give me the thumbs up. If you didn't, well, then don't. But I hope to see you on the next one. Bye.